see it done stepwise. So I'm going to use this board, and I'm going to do the equation for the Haber process, which uses nitrogen gas, hydrogen gas, which is really flammable, and it creates ammonia. And ammonia, we're used to seeing in liquids because it's really common in cleaning agents, but it actually comes out as a gas as well. And then we need to balance the equation. So we have 2 nitrogen here. We need to put a coefficient here to make 2 nitrogen. That makes 2 times 3. It makes 6 hydrogen atoms. So we need to put a 3 here, and then 3 times 2 is 6 hydrogen atoms. So each side, the reactant side and the product side, is now balanced. And the way, we don't always write a 1 here, but there is a 1 there. The way that we read this is we say 1 molecule of nitrogen reacts with 3 molecules of hydrogen to give us 2 molecules of ammonia. Or we can say 1 mole of nitrogen reacts with 3 moles of hydrogen to give us 2 moles of ammonia. And that one's more common because a mole is a chemist's dozen. So we do everything in terms of a mole. And when I do this stoichiometric calculation, I'm just going to do moles. So I'm going to say, let's say you have 2 moles of hydrogen gas, and they want to know how many moles of ammonia would you produce. So you go from moles to moles. There is only one way to go from moles of one chemical to moles of a new chemical, and that's to use the coefficients. So whenever they ask you to go from one chemical to another chemical in grams or moles or whatever unit they say, you have to have a balanced equation. So I'm going to start with what I'm given, which is the 2 moles of hydrogen gas. And again, hydrogen gas is H2. And now I'm going to use this coefficient. So coefficients, again, can represent moles. So 3 moles of hydrogen gas. And then I'm going to use this too, 2 moles of ammonia. So what that means is that it's 2 times 2 is 4, divided by 3, should give me about 1.67, and I guess I should have the same sig figs as I began with, so 1.7 moles of ammonia. So there you have seen in this how to go from moles of a reactant to moles of a product. It's just one step, and it relies on the coefficients anytime you go from moles to moles. When you're going from grams to grams, which is in another video, you also use this step, but you do it in the second step.